when we're comparing numbers, there's a couple of things that turn out to be helpful in how we work with them. And one is the greatest common divisor. So if we look at two numbers, the greatest common divisor is the largest number that divides both of them evenly. So let's look at two numbers. Let's look at 8 and 12. And first, let's identify what numbers do divide them evenly. So we know that with 8, 2 divides it evenly, 4 divides it evenly, and 8 divides it evenly. So those are the ones that divide it evenly, right? And 1, by the way, 1 always divides, but so we could even include that if we want. 1 divides every number evenly, every integer evenly. So 12, 1 divides it evenly, 2 divides it evenly, 3 divides it evenly, 4 divides it evenly, 6 divides it evenly, and 12 divides it evenly. So those are the factors, right? The numbers that divide it evenly. So a term for that is factors. So those are the factors for both those numbers. So what's the greatest one? What's the largest that is common between these two numbers? Well, you want to go, they both have 1, but those are smaller. You want to get the largest. So 12 doesn't do both, 6 doesn't do both, 8 doesn't do both, but notice here 4 does both, right? There's a 4 there and a 4 there. So 4 is the greatest common divisor between 8 and 12. And so 4 is the answer in that case. And that's what greatest common divisor means. Now let's look at least common multiple with these numbers. Now multiples are different. It's when you multiply these by integers, what values do you get? So if we take the multiples of 8, we do it by 1, it's 8. We do it by 2, it's 16. So these are multiples of 8. Right? And 32 is a multiple of 8. 40 is a multiple of 8. Notice that we can continue to go indefinitely as these get bigger and bigger, right? And 64, so we can just keep going. But what we're looking for is the least common. So what's the smallest number that is a multiple for both of these? So let's go ahead and stop and think we're going to get one before we get that any farther. So common multiples of 12. There's 12, 24, 36. These are multiples of 12, right? 48, 50, 60, 72, and you can keep going, right? The multiples. So now what we want to do is we want to find the smallest. That's the least common multiple. And common, again, it happens to both. So we start at the bottom. 8 isn't common, 12 isn't common, and 16 isn't common. But here we see 24 is the smallest multiple that is common between 8 and 12. And so that's what the least common multiple is the smallest multiple of each of them. Now, because this is a valuable thing, one of the ways that we can get to this is to actually do the prime factorization of a number. So notice here I've listed all the factors of these numbers, but these numbers are not prime. Some of them are and some of them are not. So prime numbers are numbers that can only be divided by 1 in themselves. First, they have to be greater than 1. So negative numbers are not prime. 1 is not a prime number. But anything greater than 1, any integer that's greater than 1 and can only be divided evenly by itself, and 1, right? So 1 times itself. So prime numbers are numbers like 2 and 3 and 5 and 7. And notice here I'm just going in order, the smaller 11, 13, 17, okay? And so these are prime numbers. And there's an infinite number of prime numbers. We haven't discovered them all. Some people, that's their passion and they continue to work to find larger prime numbers. But we won't be working with many bigger than these ones. So this will be a good start for us in doing prime numbers. So these are numbers that you can't divide other numbers into evenly except itself and 1. So if we do, so there's a way to do, get the prime factors of a number. So again, if we take 8 and we want to get the prime factors of it, I'm going to show you how I do this. So I start with the smallest prime number and see if I can get, and I just start with the smallest and work up. So will 2 divide it? Sure enough, 2 will divide it. And once we divide 8 by 2, we have 4 left. And then I go for the next prime number. What will divide 4? Again, I try 2, and sure enough, 2 will work, and it divides it evenly, and that leaves us 2. Right? When we divide 4 by 2, that leaves us 2. Well, what's a prime number that will go into 2? Well, 2 is a prime number that will go into 2, and then we're done, right? So we don't have anything left. So now we've factored it. It actually is 3 2s. So the prime factorization of this is 2 times 2 times 2. So those are the factors that lead to 8, and those are all prime numbers. And when we have repeated prime numbers, another way we can write them is with the, so this is the same as saying 2 raised to the power of 3. There's 3 of them, right? So there's 3 2s that are prime factors of 8. So those are the prime factors of 8. And notice when you multiply all the prime factors together, you actually get the number itself again, right? So all the prime factors together completely defines the number itself. So it's equal to 8. Let's do the same thing with 12. So let's find out what the prime numbers of 12 are. Again, I'm going to start with the smallest one, which is smallest prime number, which is 6. And when I divide 12 by it, it divides evenly. So when I divide that, I get 6. And now I keep dividing. And again, I try 2. And 2 will go into 6, and that leaves us with 3. And now 2 won't go into 3, so I can't use 2, so I'm going to go to the next prime number, which is 3. And sure enough, 3 will divide into 3 evenly, and then we're done because we've used up all of the numbers. There's nothing left to divide. So what do we get here? Again, we can use this version of using the prime number one time and then raising it to however many times. In this case, it's 2. So there are 2 2s times 3, right? Times 3 equals, and what do we get there? We get 4 times 3 is 12, and this is the multiple of primes. It's called the prime factorization to find all of the prime numbers that are factors of a number.